Geometry notes, translation, section 5, focusing on reflections. Along with translations, reflections are also an isometry, which means it produces congruent figures, also known as rigid motion. Reflections flip an image over a line. So if we take this pre-image here, ABC, and we reflect it over this line, we would want to do so in such a way that we are doing in a perpendicular manner. Perpendicular to the line of symmetry. This thing is snapping to the grid, making it horizontal when I don't want it to be horizontal. Anyhow. So whatever this distance is here, I'm going to copy that distance. I know you can't do what I just did, but if we could do it perfectly, this is how it would be. This is where B prime would be. A would be about here, A prime, and I'm sorry, that's C, not A. C prime. And then A prime would be right around here. It's not perfect. Now, if you're thinking, I can't do it. It's too complicated. It's not possible. Good news for you. If you use the power of the patty wax, you put your patty wax over top of this, and you draw the line of reflection, and you draw the pre-image, and you pick the patty wax up, and you flip it over, lining this line up. I guess when you line the line up, you'd want to also have marked maybe a point on that line, so that point's in the same location. And then flip your paper over, poke holes in these corners, pick the patty wax up, and then trace over it. Patty wax is wonderful. The pre-image is the before, and the image is the picture after the reflection. We say that triangle ABC got mapped to triangle A prime, B prime, C prime. A reflection involves a flip of an image, usually over the X or Y axis. It may also be flipped over other lines such as y equals x, x equals 2, etc. The best way to graph the image of a reflection is simply graph the pre-image, measure the distance to the line, and find the image the same distance on the other side of the line. Review of commonly used lines. How about the line y equals x? Y equals x has a slope of 1 and goes through the origin. How about the x-axis? That's the line y equals 0. We got the y-axis. That's the line x equals 0. We have the line y equals negative x, which has a slope of negative 1 and goes through the origin. These are common lines used for the line of reflection. And then there's other things that could be used that aren't as common but could happen, like the line y equals 3. That's this green line here. It's horizontal. If it's y equals a number, it's a horizontal line. If it's x equals a number, it's a vertical line. Let's say that we had x equals negative 7. That would be a vertical line when x is negative 7. All right, just wanted to review how to graph some of those things. And let's see if we can actually do a problem. Graph and reflect the preimage of triangle ABC, and we got the ordered pairs here. So let's take point A, which is here at 5, 0. Let's take point B, which is to the right 3 and down 1. Point C is 4, negative 3. That would be here. Now, if you've memorized what you're supposed to have memorized, when you reflect over the x-axis, this becomes pretty easy. Let's see if you've done it. What's the rule for reflecting over the x-axis? The x value stays the same and the y value changes sign. So if we had 5, 0, that becomes 5, negative 0, which is 5, 0. 3, negative 1, change the sign of the negative 1, becomes 3, 1. 4, negative 3 becomes 4, positive 3. This was A, B, C, so this is A prime, B prime, C prime. So A and A prime are in the same spot. B prime would be 3, positive 1. C prime would be 4, positive 3. This would be our triangle. Now, can you do this without doing all this? You sure can. Draw this picture. Then you could count spaces. Since the line of symmetry is horizontal, we go up 1 vertically, go up another 1 vertically to get B prime. To get from C to the line of symmetry, we go up 1, 2, 3. So you go 3 more, 1, 2, 3. It's where C prime is. A is no distance from the line of symmetry, so A prime is no distance. If that still doesn't work out well for you, use patty wax. Draw this figure, draw the line of symmetry, also draw the y-axis. Reflect it so that the origin's in the same location, and you will get this image. Number 2, what happened to number 2? That's odd. Let's graph and reflect. I don't know what happened to number 2. Maybe someone flushed number 2 down the toilet. Graph and reflect. Triangle rack. R is negative 5, 1. A is negative 4, negative 3. C is 1, 1 over the y-axis. So we'll do that just graphing, and then we'll go back and use our coordinate rule and see if that checks out. R is negative 5, 1. That would be right here. A is negative 4, negative 3. That's down here. C is 1, 1. That's here. Now for reflecting over the y-axis, see if we can just do this just by looking at it. So since the y-axis is vertical, we're going to reflect this horizontally. It's going to put C prime here. R has to go, was 5 units to the left of the y-axis, so it's R prime is going to be 5 units to the right. A is 4 units to the left, so it's going to be 4 units to the right. That would give us this triangle. And I made a boo-boo. C was at 1, 1, and I put it at negative 1, 1. That is not great. So let me get rid of C and C prime. Let me see if I can grab this. That's supposed to be there. I apologize. The original pre-image was supposed to be this figure, which means if I take C and reflect it, it's going to go over here. So C prime is going to be over here, which means the pre-image and the image, are overlapping. Let's check this out algebraically and see if this actually is how it's supposed to be. Well, what's the coordinate rule for reflecting over the y-axis? Change the sign of x, you leave y alone. So R was negative 5, 1. A was negative 4, negative 3, and C was 1, 1. Change the sign of x, leave y alone. Change the sign of x, leave y alone. Change the sign of x, leave y alone. So R prime should be at 5, 1, which we have it. A prime should be at 4, negative 3, which we have. And C prime should be at negative 1, 1, which we have. Cool. This got jacked up. Reflecting across the x-axis, symbol for that is reflecting across the x-axis. The coordinate rule, xy becomes x, negative y. You should know this by now. Reflection across the y-axis, symbol, abbreviation. So that would be changing x, leaving y the same. Reflecting across the line y equals x, interchange, x becomes y and y becomes x. Reflecting across y equals negative x, x becomes negative y and y becomes negative x. Parallelogram ABCD is reflected over the line y equals negative x. Graph the pre-image and the image and label the coordinates. Well, let's graph the pre-image first. A is negative 2, 4. B is negative 3, 2. C is 1, 3. And D is 2, 5. Let's mark the line of symmetry, the line of reflection. It's a line y equals negative x, which that is not it. Goes through the origin and has a slope of negative 1. So it looks something like this. Now this is not the easiest thing to reflect. So I'm going to use the coordinate rule because that's going to make this easier for me. So the coordinate rule is x, y becomes negative y, negative x. You rearrange them and you change the order. Let's see if we can do that for this. So that would be negative 4, positive 2 for A prime, negative 2, 3 for B, negative 3, negative 1 for C prime, and negative 5, negative 2 for D prime. Rearrange them and change the sign. Let's see if we can graph those. Negative 4, 2 would be here. I'm saying that's A prime. Negative 2, 3 would be here. That's B prime. This is overlapping, which makes it more complicated. Negative 3, negative 1 would be C prime. And negative 5, negative 2 would be D prime. If I connect those, making this parallelogram, If I wanted to color it in for my viewing pleasure, get a figure like this. Now, does this check out? Let's just do some spot checking. If I draw a line from A to A prime, is the line of reflection the perpendicular bisector? Sure looks like it. How about B to B prime? Sure looks like it. How about C to C prime? Sure looks like it. How about D to D prime? Sure looks like it. So that looks good. Example 4, reflect this triangle over the line x equals -3. We don't have a rule for this. Let's just see if we can figure this out. So A is -6, 2, pre-image. B is -5, +4, pre-image. C is -4, 3, pre-image. Line of symmetry is -3. If your line of symmetry is a vertical line, it makes things a lot easier. Vertical and horizontal. Diagonals are complicated. I'm just going to count spaces. From A to the line of symmetry, it's horizontally 1, 2, 3. So I'm going to go to the right, 1, 2, 3. It's going to put me right here, A prime. C is to the left of the line of symmetry 1, the line of reflection, so C prime is to the right 1. B is to the left 2, so B prime is going to be to the right 2. Cool. Lastly, find the coordinates of the following figure after reflection on the line y equals x. Well, if you know the coordinate rule for y equals x, x becomes y and y becomes x. So f prime, we just change the order. R prime, we change the order. E prime, we change the order. D prime, we change the order. Hopefully you realize that I don't make you memorize stuff for no reason. Hopefully everything I've asked you to memorize has a purpose. I like to think so. Review, solve each equation for x. When you're solving an inequality, you solve it the same way you solve an equation with one exception. If you multiply or divide both sides by a negative number, which we just did from here to here, we divided both sides by -1, inequality changes direction. Put -3 on a number line, an open circle because it doesn't say equal to, and since this is less than, we shade to the left. Number 2, simplify if we combine like terms. 12x minus x is 11x, bring down to -1. We have 2x here. -4 and a +12 is a +8. If I subtract 2x from both sides, I get 9x minus 1 is 8. If I add 1 to both sides, I get 9x is 9. Therefore, x is 1. Factor. It's a trinomial. Lead coefficient is not 1. So we are going to have to split the middle term and factor by grouping. To do that, the first term is going to stay the same. The last term is going to stay the same. But this middle term is going to get split. How do we split it? We need 2 terms that multiply to get the first term times the last term. That's 4x squared, negative style. Need the same 2 terms to add to get -3x. Those terms would be -4x and a +1x. If you add those, you get -3x. If you multiply them, you get -4x squared. So this middle term is going to be a -4x and a +x. Then you factor by grouping. GCF of the first group, 2x, leaving us with x minus 2. GCF of the second group doesn't appear to be 1, so it's 1, leaving us with x minus 2. Each of these terms have the same factor of x minus 2. GCF it out to the front. leaving us with another factor of 2x plus 1. If you're not sure if you're right when you're done, multiply it out, see if you get the original trinomial. You will. Number 4, this is a difference of two squares, which factors into two binomials. Square root of x squared goes in the first position. Square root of 36 goes in the second. It's the difference of two squares. You make one of these plus and one of them minus. You finished. Graph this equation. If I get y by itself, I have a y-intercept of 0 and a slope of -2. So from here, I'm going to go down 2 and to the right 1, down 2 and to the right 1, label the y-intercept, finished. Number 5, I'm going to get this in slope-intercept form also. Y-intercept is -4, which could be here. Slope's -1/4. I don't have a grid, so I'm just going to make it pretty sloped. Done. Please do the homework from section T5.